Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Afin Nasrullah bin Muhammad Kasbi. My number metric 14DTP 19F1033. Okay, today I want to present about a laboratory report. The title is Force Vector and Acceleration. Objective: to experimentally verify the triangle construction of a parallelogram law of vector addition by using force table. Number 2, to understand the basic concept of force vector. Number 3, to draw the phase vector diagram. Number 4, to find and analyze the resultant force and direction from force vector diagram. Introduction. Vector quantities are quantities that possess both magnitude and direction. A force has both magnitude and direction, therefore force is a vector quantity. Its units are Newton and force can cause motion. Alternatively, force can act to keep an object at rest. A force vector is a representation of a force that has both magnitude and direction. This is opposed to simply giving the magnitude of the force, which is called a scalar quantity. A vector is typically represented by an arrow in the direction of the force and with a length proportional to the force magnitude. A major feature of the force vector is that they can be broken into components according to the application of the force. Vector components are usually perpendicular to each other, although they also can be in a parallelogram configuration. Okay, basic theory. Resultant vs equilibrium. A point to be aware of this: the force need to balance the system is not the resultant of the weight. But the negative of the vector also called the equilibrium. Okay, this is a equilibrium and resultant. The R vector shows the resultant of the three vector F1, F2 and F3. If you make the vector to have a zero magnitude, then the three F1, F2 and F3 vectors are in equilibrium and their sum is equal to 0 as shown. F1 plus F2 plus F3 equals to, or F1 plus F2 equals to F3, or R equal to negative F3. This means that when the num of the three vector is 0, the resultant of any two has a magnitude equal to the magnitude of the third one and a direction opposite to direction of that third one. A scale is clearly listed. A vector arrow is with arrowhead is drawn in a specified direction. The vector arrow has a lead and tail. The magnitude and direction of the vector is clearly labeled. In this case, the diagram shows the magnitude is 26.5 degree west of north. Okay, equipment and or apparatus. Pulley. Number 1. Function pulley is a wheel and axle or shaft that is designed to support movement and change of direction. Number 2. Hanger. Function: device that is used to hook the set of weight. Number 3. Clay. Function: three add weight so that the record reading are different. Number 4. Tape roller as a pulley. Function: to support movement and change of direction of a force table. Number 5. Protector and rules. Function: tool used to draw an angle on paper and measure the angles. Okay, thank you.
Hai, Assalamualaikum. I am Muhammad Nazrul Mubin bin Sulaiman daripada from group 3 nombor metrik 14 DKM 19 F1051 and from DKM 4B section 3. So after that, tape roller as a pulley. The function of a tape roller is to support moment and change of direction of a force table. Protector and rule. The function of protector and rule is to use to draw an angle on paper and measure the angle. The procedure is: first, set up the apparatus and equipment. Second, hanging the right weight for each angle given and mark the direction of force and direction force value. Third, record the data and the end of the experiment. Fourth, calculate all the force using on X and Y axis. 5. Repeat the step 2 to step 4 for 3 times with different weight. Assumption. First, the mass of the string is eligible. The pulley are frictionless. The strings are very thin so that the direction can be marked out accurately. Result and calculation and data analysis. So it will be like this. Force number 1 is 0.69. Force number 2 is 0.59. Force number 3 is 0.83. Symbol is F1, F2 and kg. Force weight 0.69, 0.59. Angle is, both of them is 60 degree. And the kg1 is 90. Calculation and data analysis. Resultant force. 0.83 Newton. X is known. Y is 0.83 Newton. 0.59 Newton. X is 0.59 cos 60 equal to 0.295. And for the Y is 0.59 sin 60 is equal to 0.511. 0.69 Newton when X is negative 0.69 cos 60 equal to 0.845, and Y is 0.69 sin 60 equal to 1.959. FR 0.05 the power of 2 plus 1.958 the power of 2 equal to 3.758. Punca kuasa equal to 1.938 Newton. Degree equal to tan minus 1 kurungan 1.938 per 0.09. When we press the calculator equal to 38 degree. So the conclusion is, when we place a mesh fault holder equal for the magnitude of the resultant, the ring turn to equilibrium. That means the fault mesh is equal to the resultant force of the degree mass. The experiment proved that has direction as an resultant force consists several vector force. A vector is a quantity having a magnitude and a direction, and two vectors of the same type can be added. And The reference book is physics book, www.slideshare.mechanic.net, and number 3 is www.engineeringmechanic.net. That's all from group number 3. Thank you.